Alright, so this is going to be a video lesson for section 9.8, the last section in chapter 9, which is the second to last section that we'll work in. 9.8 is factoring special products. So these are special cases in factoring. And with just like most special cases, there are shortcuts. So I'm going to show you a pair of shortcuts here that help you factor out problems that would otherwise take a long time to factor them out normally. Now, all of these problems can be factored out normally through using the trial and error method or the diamond method, but the shortcut allows you to do this much quicker. So the first shortcut is if you have a problem that is in a form of something squared, so let's say an a squared minus something else squared. A can be anything, B can be anything. So the A, I'll highlight the A here. So the A, for example, can be a 5, it can be an 11, it could be an X, it can be a Y, it can be a combination. It could be 5X, it could be 11Y. So the A can be any of these taken to the second power. And same thing with B. B can be, any of these as well. And that means the same. So A and B can be any number, constant, or a combination of the two taken to the second power. So if you have A or B squared, and it's a subtraction, there's a minus between them, A squared minus B squared, you can write it in this form. A plus B parenthesis times A minus B parenthesis. Doesn't really matter which one goes first. They'll work in both cases. So for example, let's say my A is an X. So for example, let's say I say that A is an X, and let's say that B is a 2. Pretty simple case. If you see a problem like this, where it's an X squared minus a 2 squared, you can always write it down as such. 2 parentheses, X here, 2 here, 2 here, and the signs have to be plus minus. One has to be plus, one has to be minus. Doesn't matter which one's the plus, which one's the minus. So pretty easy shortcut. You don't have to do any factoring. Now do keep in mind that most of the time you will see the 2 squared written as a 4. Very rarely will they actually write 2 squared. They'll typically write any numbers in their they'll remove numbers from exponential form and they'll write them in their worked out form. So you won't see 2 squared, you'll see a 4. You won't see 3 squared, you'll see a 9. You won't see a 4 squared, you'll see a 16. So typically you have to kind of decipher them. If you see a perfect square, well, there you go. So let's do another example here. If I gave you a problem like this, let's say y squared minus 36. Again, the number is almost never written in its exponential form, but we know that 36 is just 6 squared. So I write my 2 parentheses. So if 36 is 6 squared, it's the same as y minus squared minus 6 squared. So I can write a y here, I can write a y here, and on the other set of terms, I'll write a 6 and a 6, and the signs have to be plus minus or minus plus. I'll write a minus plus. This time it makes no difference if the minus goes where the plus goes first. Let's do another example. Let's say I have a 4m squared minus a 9. Okay. Remember I told you that A and B can be actually a combination of a number and a variable. So in this case, this is the same thing as I'm going to color code it. Same thing as 2 squared m squared minus 3 squared. And I can further rewrite this as 2m, we'll take them to the second power since they both have a power of 2, minus 3 squared. And now that I have this, I can write it in the a plus b with the a minus b format, with the 2m being the a and the 3 being the b. So I write my two parentheses. And then I will write 2m here, 2m here, and I'll write a 3 here, a 3 here, and again a plus or a minus here, and then if you wrote a minus before, then it would be a plus then. If it's a plus, then it would be a minus there. So what if I had a problem like this? So let me flip the page. So what if I had a problem that looked like this? 32 x squared minus 50. So you're looking at this problem, and the 32 is not a perfect square. There is no two identical integers that multiply together will give you a 32. Same thing with 50. They're not perfect squares. When you look at a problem like this and the formulation of the shortcut isn't jumping out at you, always try to factor something out. See if you can factor something out. Well, in this case, they both share a factor in common, and that's 2. You can factor 2 out, can't you? And if you do this, you'll end up with 16x squared minus 25. Now, 16 is a perfect square, so is 25. So I can write that down as, still the 2 outside, is 4x all taken to the second power minus 5 squared. Which means that my a is the 4x and my b is the 5. Excellent. So now, still keeping the 2 on the outside, I'll make my two parentheses, and I'll do my a plus b, a minus b form using just that. So it'll be 4x, 4x, it'll be 5 and 5, and it'll be plus minus, minus or plus, doesn't really matter. Plus minus, I like to start with a plus. And that's it. So if a problem doesn't look like it's going to work out through the shortcut, don't despair yet. Try to factor something out. In a lot of cases, that's all you need. Once you factor something out, you should be able to obtain the form that is applicable to the shortcut. Sometimes you won't be able to. This is a special case, and if it's not one of these special cases, then you won't be able to use a shortcut. So it doesn't work every single time, but if it does, it's very clean, very simple, very easy. So that's the first shortcut method. Then there is another shortcut method, so let me show you that. So this is the second shortcut method, and if you recall, both of these shortcut methods are essentially reverses of the special cases we learned at the end of chapter 8. So these are the special cases of for chapter 8 problems, and we're just working them in reverse for the factoring purposes. So if you have a problem like that, the first thing that you need to do is figure out if whatever problem you're given is set up in this form. So for example, let's say I give you this particular problem. I give you an x squared plus 6x plus 9. So that's a problem that you're told to work out. Well, you actually know how to work this out. You can factor this problem out, just by doing the two parentheses, writing x in the first position, and then figuring out what adds up to 6 and multiplies to 9. You can do that. And obviously in this case it might not be too much of a proposition to work this problem out because it's a simple one. But I just chose a simple problem to start with. Now let's see if we can use the shortcut to apply to this problem. So for the shortcut to work, this problem has to be in the exact same format as that. In order for us to do that, we have to see if the A and the B from here work here. So if this problem works as a shortcut, then the A squared has to correspond to this, and the B squared has to correspond to this. Okay, fair enough. If that's true, then we have to be able to get an A and a B monomial or value out of these two. So if A squared is an X squared, then the A will be just an X. Sure. Makes sense. If A squared is the X squared, then the A should be just the X. With the 9, don't forget that you can rewrite this 9 as a 3 squared. 3 squared is a 9. So if B squared